Okay, so here is the second video on forces. This is for your Physics Paper 2 paper, and it's on motion graphs. And we've got two different types of graphs you need to know about. You need to know about distance time graphs first of all. Here we've got a story. A bike travels 50 meters in 5 seconds at a constant speed. So what does that first sentence look like on a distance time graph? First of all, let's just look at a distance time graph. A distance time graph has distance on the y-axis and time on the x-axis. So this first sentence, a bike travels 50 meters in 5 seconds at a constant speed. 50 meters on the y-axis, 5 seconds, and the constant speed is shown by the fact it's a straight line with a positive gradient. So a straight line with a positive gradient means that the object is moving away from where it started at a constant speed. The next sentence is that the bike then stops for 15 seconds. So from 5 seconds, that's the first part of its journey. For the next 15 seconds, it's stationary. So 15 plus 5 is 20 seconds. So if we go up to 20 seconds, you can see here, it hasn't moved from 50 meters. So a flat horizontal line on a distance time graph means that the object is stationary. The bike then travels another 50 meters in 10 seconds. So hang on, 50 meters, another 50 meters. If it was already at 50 meters, 50 plus 50 is 100. So it's going to finish off at 100. And it's taken a further 10 seconds to do that. So it's at 20 seconds at this point, so 10 plus 20 is 30, and you can see that, roughly speaking, at 30 seconds it's reached 100 meters. But how it's done that is different to how it got to 50 meters at the start. You can see here, look, to do this 50 meters in 10 seconds, the first 3 seconds it's been accelerating, and I've shown that by the blue part here. So this is showing acceleration. A curve on a distance time graph means either acceleration or deceleration. So if it's curving upwards, that means the object is accelerating, and that's what's shown here. For the first 3 seconds from 20 seconds, it's accelerating. Whereas deceleration shows that it's kind of curving and flattening out, and that shows deceleration. Now there's two things you need to be able to do on a distance time graph. The first one is to be able to calculate speed, and that's just average speed. So if we look at this first part here, all you have to do is find the gradient of that line. And you find the gradient by doing the change in y, the rise, divided by the change in x, which is the run. So if we do that, 50 divided by 5 is going to be 10 meters per second. So for this part of the journey, the speed of the bike is 10 meters per second. Okay? But you could also be asked to calculate the gradient at a certain point, to calculate the speed at a certain point when the object is either accelerating or decelerating. The way in which you do that is you need to draw something called a tangent. So if I wanted to find the acceleration at, say, 23 seconds there, I'd need to draw a tangent, a line that is a tangent to that point. And then I simply find the gradient of that line by doing the change in y divided by the change in x. So on a distance time graph, you could be asked to calculate two things. One is just the speed at a certain point, which is distance divided by time, which is the gradient of a straight line. Or it could be the speed at a certain point where it's accelerating or decelerating, which is where you need to draw a tangent and find the gradient of that tangent. Moving on to the second type of graph you could be asked about, and they're quite similar, guys, so you've got to be really careful in terms of thinking about what the shapes look like on both graphs. The second type of graph is a velocity time graph, and once again we've got a story here. We'll start with the first sentence. A bus travels at a constant speed of 5 meters per second for 10 seconds. Well, what does that look like on our velocity time graph? Here we've got velocity on the y-axis, and we've got time on the x-axis. In that first sentence, a bus travels at a constant speed of 5 meters per second for 10 seconds. It actually just looks like this. Here you can see the velocity axis goes up by 2, 4, 6, 8, 10. So if you go to 5, it travels at 5 meters per second for the first 10 seconds. So a straight horizontal line on a velocity time graph means constant speed. And hopefully you can rewind it to see that that is different to what that shape looks like on a distance time graph. That means stationary on a distance time graph. The next sentence is that the bus then stops for 30 seconds. Well, if we have a look, that means the velocity, if it stops, that means the velocity's gone down to 0. So you can see this graph goes down to 0 for the next 30 seconds, up to 40 seconds. 10 plus 30 is 40. The next sentence says the bus then accelerates for the next 5 seconds. And acceleration on a distance time graph is a straight line with a positive gradient. So that's showing acceleration for the next 5 seconds. It was at 40, by the time it's got to 45, it's accelerated. before once again moving at a constant speed of 10 meters per second for another 20 seconds. So you can see it's just the story here, look, from 45 up to 65 seconds, that's the 20 seconds we've got here, it's moving at 10 meters per second, the constant speed there. And then the bus decelerates for the next 5 seconds, as you can see here, to rest. And rest means it's stationary. So it's reached, at 70 seconds, it's back to being 0 meters per second, it's back to being at rest. Now, once again, there are two things that they can ask you about in this for a velocity time graph. And the first one is actually really easy, but one that students often forget or just don't know what to do. You could be asked at any point in a journey on a velocity time graph to calculate the distance that the object has travelled. Let's look at this part. Let's say the question asks you to calculate the distance that the bus travels in the first 10 seconds. Well, because you know distance is speed times time, velocity times time, all you're doing is calculating the area of this rectangle. And the area of a rectangle is the base times the height, the length times the width. So the area of this rectangle is going to be 5 times 10, which is 50. So the bus has travelled 50 metres in this part of the journey. The second thing you could be asked about is to calculate the acceleration or the deceleration. And the way in which you do that is just calculating the gradient of any one of these lines. So when you see a diagonal line with a positive or negative gradient, you calculate the gradient of that line to calculate the acceleration or the deceleration. So look at this bit here. Gradient is the change in y, the rise, divided by the change in x, the run. So the change in y for this one is 10, and the change in x for this one is 5. So the gradient of this blue part of the line is 10 divided by 5, which is 2. So we can say that this bus is accelerating at 2 meters per second squared due to calculating the gradient of this line.